Assalamu alaikum. My name is Hamda and I will explain the component of our prototype. Here we have two aluminum plates in our model, unlike the original model which had 6 plates made of plastic and aluminum. They are connected to a shaft by welding. And the end there is a bearing that helps the plates rotation. The original model had 3 solar panels, but in this model we made them 2 with 30-watt capacity, also to reduce weight and make them move in and out freely. We use 4 wheels, 2 fixed and 2 free to move, for easy movement. We put the cover to hide the internal component and add beauty to the turbine. Now my colleague will complete the rest of the component.
Assalamu alaikum, my name is Nجود and I will continue explaining the rest of the turbine components as well as the power output. We used the anemometer to measure the wind speed, which was an average of 4 meters per second. So, as shown now, that's how to measure the AC voltage output, which approximate to 2.5 voltage. This shown connection is to measure DC voltage output, which approximate to 2.8 volt. This small device with a red light is a booster, which is a DC generator whose function is to inject or add a certain voltage into a circuit to compensate for the voltage drop in the feeder, and it's used towards the end of a power line to raise the voltage to the desired value. And now we put the turbine into the sunlight in a way that the solar panels fixed to take as much as possible of sunlight. So the voltage output as shown in the solar charge controller is 12.1 volt. So this footage shows the easy movement of the solar panels and an inside peak of the holder. This middle piece is to hold the plates in place while it's rotating and prevents by vibration. And unlike the previous turbine, the generator is connected to the shaft for efficiency purposes. That's all about the inside of the turbine and its components and the electrical connections. So my colleague will continue on to compare between the old prototype and this new prototype.
Here we are going to compare the inside of the turbine where all components are. As we can see, the older generation has a similar inner components as the newer generation, with minor changes to improve the efficiency of the charging outcome. We have the generator, the shaft, the battery, and the electrical connection. The original position of the generator was on the side of the box, and the blades were connected with the shaft through a wheel and belt mechanism. The improved generation of the turbine has the generator installed directly in the middle of the box, and it's fixed directly to the shaft blade. Made maintenance for the generator to improve its efficiency. We used the method of argon welding for the generator holder, then installed the shaft and aligned everything. Here we have the electrical connections. We use the same connections as the older generation. switch is to be able to charge larger devices. For the accessories, they were on the outside originally. We made bigger slots for it to be installed from the inside to have only the outside part showing. And we can see here how it all is installed.